So now if so this is clear, right? The next one, the most important one in this case, is now finding out the reinforcement dia. Okay, now it is the reinforcement dia. So now we will again jump into the whiteboard. So now the first and foremost thing is diameter of confining reinforcement. Okay, now before jumping into this finding the way to find the diameter, what I will do, I will just go back to the previous one, which is designed for shear force in columns, and here I will be discussing this particular diagrams. So if you see here, in this particular diagrams, this clauses also discussed actually. So rather reading these clauses, I will directly you can say explain with this diagrams. Okay, it will be much better for understanding. Okay, you can read it out and you can understand later how these diagrams are helping you to understand, right? So now the same diagrams, actually amendments are there. So what I will do, rather discussing on this diagram, I will go to the amendment where you will be getting the amended clauses. So I will directly go to the amendment here. Yes, fine. So here it is given. So now here the first thing is that when you have columns, so in that case, based on the column dimension, we are distributing the reinforcement, right? So this center to center dimension of your main reinforcement, the code says that if the center to center dimension in each direction in your column, if it crosses 300 mm, in that case we need to provide a additional link to connect the intermediate bars. Okay, we need to provide an additional link to connect the you can say intermediate bars. So if you see in this case, case 1, if you see, it is clearly seen that this center to center dimension for the main bars, it is less than or equal to 300. Okay, suppose this, let us say that this dimension is 300 mm. Okay, so rather writing it here, what I will do, I will write it in my whiteboard so that you can refer it later. Okay, so suppose we have a column, and as we have columns, we will be having stirrup, and we will be having the main reinforcement. Suppose like this. Now if this column is 300 mm by 300 mm, considering the clear cover as 50 mm, okay, so if I write clear cover as suppose 40 mm, okay, clear cover 40 mm, so in that case what will be the center to center distance? Suppose these bars are of T20 dia, right? So the center to center distance will be, this is my 25 mm, so this is 25 mm, and then again half of the bar. So this distance we are getting 35 mm, right? 25 plus 20 by 2, so half, 10 mm, sorry, no, it is wrong, it is not 35. 25 plus, if this stirrup is, suppose this stirrup is of T8 dia, okay, so then 25 plus 8 plus 20 by 2, So how much? 25 plus 8 plus 10. It is 43. So both direction 43. So this center to center we are getting basically 300 minus 2 into 43. Okay, so 214, which is less than 300 mm. Okay, so if this distance is less than or equal to 300 mm, in that case there is no requirement of any additional tie. You can provide a rectangular tie itself, right? Rectangular tie itself. But when your column dimension is something like this, okay, and you have provided stirrup, fine, you have provided stirrup, and so in between we have provided, suppose, bars like this. In between, suppose we have provided bars like this. Okay, so this is our main link, rectangular link. So in that case, if you see, if this is 500 by 300 column, so what will the center to center distance of these bars? If you see, I just show you. See here, these bars, what is the distance we are getting? So in that case we are getting 500 minus 2 into 43. I'm considering that I have provided similar reinforcement dia and similar clear cover and tie. So 2 into 43. So how much we are getting? 500 minus 2 into 43. Right? So it is 414, which is greater than 300 mm. So it is not okay. So in that case, we need to provide some intermediate links also. Okay, we need to provide some intermediate links. Suppose in your column, if you provide this dimension, and if you provide reinforcement only in this ends, so there is no requirement of this intermediate we can say reinforcements. With this reinforcements only, suppose this is not there, this particular part is not there, then only it is passing. Obviously we will not provide this basically, because then in that case we'll be reducing the size. But still, for some reason you have provided some dimension which is required, and you are seeing that this reinforcement itself is enough. Still, as this dimension is more than 300 mm, you have to provide minimum reinforcement in between to provide these transverse reinforcements. Okay, so this parallel legs should not be more than the spacing between the parallel legs of stirrup. Okay, this parallel legs. Okay, this is one leg, this is one leg, these are parallel. So spacing between the parallel legs of the stirrup should not be more than 300 mm. So what you have to do, suppose these are higher dia bars, so in between you just have to provide the minimum reinforcement dia, maybe 12 mm dia, and you have to provide link like this, transverse reinforcement like this. Okay, so in that case, if you see, I have provided 190-degree you can say bend, and another one is 135-degree bend. If you're providing like this, then what you have to do, this should be like zigzag pattern. So one is here, another one is here, 2 is here, another 2 is in the opposite direction. Okay, so like this you can see here. If you're providing one, okay, fine. When you're providing this multiple number of you can say links, so in that case you'll be providing like this. This 8D already I have discussed. One more thing, if the center to center, let me suppose this is my column, this is my stirrup, and I am providing bars like this. Let me draw properly. Suppose this is my stirrup and I have provided bars like this. Okay, so if these center to center spacing, suppose if these are less than 75 mm, if these are less than 75 mm, so what you can do, rather providing link to each of these bars, you can provide link to the alternate bars like this. This will be my main link, and I can provide link to the alternate bar, so you can leave one of the middle bar like this. Okay, if in case it is less than 75, so if you read 456, you can get this particular criteria. Actually, that we will discuss later, that is a link criteria. But now, as we are you can say discussing confinement reinforcement, so obviously this also you have to know when you're providing confinement reinforcement. Okay, because the if the spacing of the links are very less, like less than 75 you are getting, so that is not required actually as per IS 456. The parallel legs, the distance between the parallel legs of the transverse reinforcement, if it is less than 75 mm, we can provide one particular one bar, and alternate bars we can link actually. So maybe what you can do, like suppose you have like this, so this is one bar, obviously we need to provide. Okay, I think like this. What you can do, rather providing individual links, you can provide another link, total link like this. Okay, or the second case you can do like this. Sorry, so you can do like this also. Okay, one. So suppose this is 75 mm, less than 75 mm, so you can leave one, you can provide another one here, you can leave this and you can provide here. Over, this is also okay. Okay, if it is greater than 75 mm, then all these links need to be tied up. So here also, if it is greater than, then we'll be providing like this in that case. Okay, so this we will discuss when we will be doing the detailing part, right? So that is a detailing part. This basics at least we all have to know, though these drawings will be made by the draftsman or the designer, but we are the engineers who have to provide the input to them, right? So in that case, we also have to know the basics at least while giving the drawing input, right? So now our aim is to find the diameter bar. So if you just go to this here, there is some terms given which will be required actually while finding the diameter. So you can see here, this it is written as the BC, which is less than 300 mm, and the HC, which is less than 300 mm. So here basically HC is nothing but the higher dimension, okay, or the dimension along the depth. Now here also, if you see, this BC is less than 300 mm, and now which will be the HC in this case? In the second case, if you see, in the second case, which will be the HC? Whether it will be this one or whether it will be this one. So the HC is basically the outer to outer, the farthest you can say reinforcements. But here you can see there is one is HC dash we are getting, which is, suppose you have provided one link in between, what it will do, it will break the total length of this particular, stirrup. It is breaking it here, right? So the place where it has broken, so we have to take this dimension as the dimension of this particular length of the particular leg. It is broken here. This leg is broken. Broken means it is not discontinued, but we have provided one particular link here to connect, support it. Fine. So now if I just, what I will do, I will just jump into the formula. Then only you can understand how it is. So if you see here, so now the C's have a area, ASH. Area means cross sectional area. Okay, this is the cross sectional area. Okay, it is the cross sectional area. Okay, so cross sectional area, that means the bar that we are going to provide, that bar must have cross sectional area of the section of the bar forming links. Okay, have a area ASH of cross section of the bar forming links or spiral at least. So that I have you can say I have told you, in circular links or spirals. In case of circular or spiral links, this is the criteria. ASH maximum, it should be maximum of 0.09 SV dk. dk means diameter of the core, FCK by Fy. So this is the formula. AG is the you can say gross cross-sectional area of the column, and this is the cross-sectional area of the core of the column, and 0.024 SV is nothing but the spacing, dk is diameter of the core, FCK by Fy. So this is for circular or spiral links. So now this you will understand easily if we discuss the rectangular one. So I will just jump into the rectangular one, because our problem is with rectangular one. So here you can see this is the rectangular one. So it says maximum of 0.18 SV into H. Now what is this H? What is this H? We will discuss. FCK by Fy we understood. Compressive strength of concrete, yield strength of steel, gross cross-sectional area of the concrete. AKA we will discuss. Okay, same 0.05 SB H FCK by Fy. Right, so these two formulas we are going to use for the rectangular or square columns. Right, so now if I discuss this, easily you will understand the other one also. That means the spiral or circular one also. So what I will do, I will write it here. So I will write it here, diameter I will be providing. So ASH equal to, so this is the thing about the cross section. Okay, don't be confused, this is not the diameter, this is the cross section. So ASH equal to maximum of 0.18 SB H FCK by Fy AG by AK minus 1, or 0.05 multiplied by SB multiplied by H multiplied by FCK by Fy. Okay, multiplied by FCK by Fy. Correct? So now if I take one example, so basically this H that you are seeing here, it will be the greater of this HC dash or BC, whichever is greater. Okay, if you see this HC dash and BC we have, whichever is the greater value, that will be considered as our H in this particular formula. In this particular case also, HC or BC, taking that this both the dimensions are less than 300 mm. So in that case, whichever is the greater will be considered as the you can say H. In this case also, where multiple links are provided, here also we have you can see here we have this HC dash, right, HC dash, equally distributed, and BC dash, BC dash. So among these values, whichever is the greater value, that will be considered as a considering as a H. Okay, we'll be considering as a H, right? So if I just take an example to explain actually, so I will. And what is this core area? So that will also I'll explain while taking the example. So I will take an example. Suppose we have a column. Okay. So we have a column, then we'll be providing syrup. Okay. And we will be providing some reinforcement in this. So maybe 1, 2, 3, 4, 5 each direction, and this direction 4, 4, 5. Fine. Okay. And if the dimension is 300 by 500. Okay. So if I find this bar to bar dimension, how much we are getting this bar to bar dimension? How much we are getting this bar to bar dimension? Considering 40 mm clear cover, 40 mm clear cover, and what is the bar dia we'll be considering? What is the bar dia that we'll be considering? So suppose we have considered a bar dia of 16. Suppose these are the T16. Fine. So if I just find this, suppose this is my BC dash equal to how much we are getting. So the cover, effective cover that we are getting, it is 40 plus 8 plus 16 by 2 means 8. So how much it is? Sorry, 56 or what? 40 plus 8 plus 8 plus 8, it is 56. Okay, so both side 56. So 300 minus 56 minus 56, we are getting 188. Is it correct? 188 or 184 we are getting? 3 minus. Oh, okay. This is one case. Fine. Okay. Okay, 188 for, or if I consider this as 10 mm dia, let us consider this is as 10 mm dia. In that case it will be sorry, in that case it will be how much? 50, 40 plus 10 plus 8, so 58. So 300 minus 58 minus 58, so it is 184. So if it is 8 mm, then so for 10 mm it is 184. So this is for 10 mm dia stirrup, and 188 for 8 mm dia stirrup. Now we are considering 10 mm dia stirrup, suppose, so it will be 184 mm, right? So which is less than 300 mm. So in between there is no requirement to any extra link, right? But here if you see this HT, how much we are getting? So we are getting 500 minus, considering 10 mm dia bar, so it will be 500 minus 58, right? So 58 minus 58, So it will be 384. 384, which is greater than 300 mm. So what we have to do? We have to provide some additional link here. So I will provide, suppose, one additional link here. Okay, I'll provide one additional link here. Sorry. So now what will be this dimension? Now another, this is the length of this particular leg of the stirrup is broken here. So now we can call it as HC dash, which is equal to how much we can say? So we can say half of this 384, right? So 384 divided by 2 equal to 192. It is 192 mm. So now it is fine. So here, which one will be considered as H? So H equal to max of BC dash and HC dash. Okay, maximum of BC dash or HC dash. So which one is maximum? So here HC dash is equal to 194, which is maximum. So it will be considered as a H. Right? Maximum or minimum? I also forgot. Let's give me 1 second. It is maximum of A and B. Correct only. Then why we have considered, just let me see. Actually I have done the back calculation, so I'm just checking whether I have done anything wrong. $384, to make it half, it will be here. So 192. Let me see what code says about this. H shall be larger of HC and BC. Okay, that is what code also saying. Here if you see in this formula, H is the longer dimension of rectangular link measured to its outer face, which does not exceed 300 mm. C10B. So 10B, this one, right? Which does not exceed 300 mm, it has said. And also said that the longer dimension of rectangular link measured to its outer face, which does not exceed 300. Fine. Okay. So in our case, it will be 192 mm. So H equal to 192 mm we have considered. If there is any mistake, please do let me know in the chat so that I can correct it later. In the next lecture I will correct it. Okay, I think this is what the code says, that this is the longer dimension we are getting, and if we break it by providing an additional link in between, so in that case we are getting the dimension which is 192, which is less than my 300 mm, right? So in that case, this dimension and this dimension, whichever is the less it's a larger one, that will be using as our H here in this formula, H. Okay, fine. And spacing, we have found out that 75 mm spacing we are providing, right? So if I just use ASH equal to, so ASH equal to case 1 is what? You see the formula, 0.18 multiplied by SV, which is 75 mm, multiplied by H, which is 192 mm, okay, multiplied by FCK by FY, multiplied by FCK is suppose 25 Newton per mm square. Okay, considering M25 grade of concrete, and Fy is nothing but the, let me see Fy whether it is for the shear reinforcement or main reinforcement. So 0.2% proof strength of transverse steel reinforcement bars. Okay, so rather considering 500 mm, we'll be considering 415 actually for the transverse reinforcements. Okay, so 415 multiplied by, is there anything else? Yes, AG by AK. So AG is the gross cross sectional area. So what is the gross cross sectional area? Gross cross sectional area is 300 by 500. And what will be the AK? AK is this nothing but, AK is nothing but this core. AK is nothing but this concrete area in this core. Okay, concrete area in this core. So this is my AK. So tentatively you can consider that this is nothing but this 184 multiplied by this 384. So 184 multiplied by 384. Okay, minus, I think there is one other value which is minus 1. Okay, so this is nothing but the AK we have considered, this cross-sectional area of the core. Fine. Okay, so now if I just calculate this, how much we are getting ASH. So here ASH1 we are getting, to do it here, 0.18 multiplied by, to see here, let me make it a bit small. Okay, so 0.18 multiplied by 75 multiplied by 192 multiplied by 25 by 415. Okay, multiplied by here 300 multiplied by 500 divided by 184 multiplied by 384 minus 1. Okay, so you are getting a value of 175.34 mm square. Okay, this is case 1. Now if I just go to the case 2, what case 2, what is the formula for case 2? It is 0.05 SV. So 0.05 multiplied by 75 multiplied by H into FCK by Fy. So H is nothing but 192 multiplied by 25 by 415. Right? So ASH equal to 0.05 multiplied by 75 multiplied by 192 multiplied by 25 by 415. Sorry, 25 by 415. So we are getting a value of, is it correct? Wait, 0.05 or 0.5 only, let me see. 0.05 SVH, right, correct only. Correct only. So we are getting value of 43.37 mm square. So this is my ASH2. So we need to get maximum of ASH1 and ASH2. Right. So which was the maximum? ASH1 is the maximum, equal to ASH equal to 175.34 mm square. So that means now you have to provide a bar. You have to provide a bar whose cross-sectional area is more than or equal to 175.34 mm square. So if you provide 10 mm diabar, it is only 78.5 mm square. If you provide 12 mm diabar, it is only 112.112 mm square. So if you provide 16 mm diabar, then it will be 201 mm square, right? So that means you cannot provide 10 mm diabar in the stirrup, means this confinement reinforcement. You cannot provide 12 mm diabar. In this case, you need to provide this 16 mm diabar in your confinement reinforcement. Okay, fine. So now the problem is that it is very odd to provide 16 mm diabar in the confinement reinforcement, right? It is very odd to provide 16 mm diabar in the confinement reinforcement. So in that case, what is the alternate way that we can do? What is the alternate way we can do? So the alternate way, what we can do, the second case, what we can do, the same column we will draw here. Okay, the same column we will draw. And let me provide similar reinforcement. Okay, let me provide similar reinforcement. This is a trial 2, because this, it is not possible to provide, like it is not feasible to provide 16 mm diabar in the confinement reinforcement or in the stirrups. So I will do 1, 2, 3, 4, 5. Okay, sorry, 1, 2, 3, 4, 1, 2. Now this is also 300 by 500. Okay, and this is 16 mm diabar, this is 10 mm diabar. Suppose there we have just this thing is just for calculation of you can say clear cover, effective cover, we have just assumed, but it is not the determined. Okay, this is just assumption, remember. Okay, this is not the fixed one. The finally we are getting the answer as this 16 mm diabar. So here we are assuming 10 mm diabar. Suppose here also we are assuming 10 mm diabar. So if we assume 10 mm diabar, so 58 will be your effective cover in case of 16 mm diabar, right? 50, 16 by 2, 8, yeah, 58. So now, rather providing only one link, what we can do, what I will do, suppose I'll provide another link like this, and I'll provide one more link like this. Okay, one more link like this. For this, suppose we have, okay, fine, right? In this direction, in the other direction also, what I will do, in the other direction also I will provide another link like this, maybe this direction. Fine. Now you can find out the you can say BC and HC. So BC now it will be this. It will be this. So previously it was 184. So if I just divide 184 with 1, 2, 3, so just generally I am doing 184 divided by 3, so 61.33. So you can see this we are getting 61, this we are getting 61, this we are getting 61. So this is, all these are nothing but my BC dash, right? Okay, and here 1, 2, 3, 4, 384 divided by 4. If I do 384, because earlier this outer dimension it was 384, so 384 divided by 4, it is 96. So all these are 96, 96, 96, 96. So these are my HC dash. Fine. Okay. Now easily I can find out. Again the case 1. Again the case 1, 0.18 multiplied by I used to forget actually, 0.18 multiplied by the spacing 75 mm multiplied by h, right? H. So here our h will be greater of these two. Obviously h will be 96. That is my h. So 96 multiplied by FCK by FY, right? Yes, FCK by FY. So 25 by 415 multiplied by AG by AK. Okay. So AG, it will not change. 300 by 500. AK is 184 multiplied by 384. Right? The core area minus 1. So how much we are getting? ASH1 here in case of this, we are getting 0.18 multiplied by 75 multiplied by 96 multiplied by 25 by 415, right, multiplied by 300 multiplied by 500, okay, divided by 184 multiplied by 384 minus 1. Okay, so you can see from 175 mm square, okay, from 175 mm square to 87.67, sorry, 87.67 mm square, it has came down. Okay, so if I do the case 2, it is 0.05 into SV into H multiplied by FCK by FY. How much you are getting? In this case, 0.05 multiplied by 75 multiplied by 96 multiplied by 25 by 415. Okay, so we are getting 21.68 mm square. So we'll be considering, so this is my ASH2. So maximum of ASH1 and ASH2 is equal to how much we are getting? 87.67 mm square. Right now, if you see here, 8 mm diabar, sorry, let me write with different colors. 8 mm diabar is equal to 50.2 mm square. 10 mm diabar is equal to 78.5 mm square. Okay, 12 mm diabar equal to 112 mm square, right? So in this case 8 mm diabar we cannot provide, 10 mm diabar we cannot provide, so we'll be basically providing 12 mm diabar for this confinement reinforcements. Sorry, I just closed by mistake. Yes, so we'll be providing 12 mm diabars, sorry, 12 mm diabars for this confinement reinforcement. So what is the ultimate answer we got? So confinement, so 3 answers we needed, right? 3 answers we needed. What I will do here, I will draw the column again to write all these answers. So this is my column, this is my one beam, this is my another beam, right? So we'll be providing confinement reinforcement like this, here also like this. Okay, so this extent L0 equal to 500 mm, L0 equal to 500 mm, this spacing and bar dia. So we'll be providing 12 mm dia bar at the rate 75 mm center to center. Here also we'll be providing 12 mm dia bar at the rate 75 mm center to center. So this confinement reinforcement, this bar size and the arrangement all depends on the ties that you are providing, and this BC and HC dimension that you are getting, means the arrangement of your you can say transverse links and the main link. Based on that only you are getting the diameter of the confinement reinforcement. Okay, based on that only you are getting the diameter of the confinement. Okay, so alternatively, now if you suppose the 12 mm dia bar also you cannot provide, you have restriction to provide only up to 10 mm dia bar, so you have to think about something else. So maybe you have to provide one more layer of bar here, maybe not required but still 12 mm dia bar, and provide another transverse reinforcement here to reduce this dimension, and you have to check that how it is affecting your result. Okay, how it is affecting your result, because here you can see this value is affecting your result, which is nothing but the HC or HC dash. Okay, or you can say H. So these two, whichever is greater, that greater value should be lesser value, so that you can get a lesser amount of ASH. Right, lesser amount of ASH. Again, this spacing also depends. This spacing also depends. Right, spacing also depends. If spacing is more, you will get higher reinforcement there. Okay, so I hope this confinement reinforcement thing for the columns, it is pretty clear to all of you how we'll be finding the bar of the confinement reinforcement. So this is what actually say given in our code. Okay, H link could be reduced by introducing cross ties, that whatever I have just discussed, that this H can be reduced by providing introducing cross ties in such a way that AK shall be measured as overall core area regardless the link arrangement, hooks cross ties shall engage okay, this is nothing but the description they are saying. Fine. Okay, so this all these things you can just read a bit for your understanding, and I have already discussed this actually. I have already discussed this. Okay, correct, fine. Now we can see for the circular and you can say circular and spiral also, right? So this is the diameter. So if it is a circle, it is something like this, and you're providing link like this. So this is my core area. So this diameter, if you know, okay, so you can know that core area also by deducting this. You will get the diameter, and pi by 4 d square, you will be getting the core area, which is this AK. So this is nothing but like this. Just these factors have changed. Other than this area earlier it was AH, sorry H. Now it is DK. DK is diameter of the core of circular column measured to outside of spiral link. So this is the diameter of the core. Easily you can find by reducting this particular area. Correct? Okay, so this you can do by yourself. This is your task that you have to find out by yourself for taking any example. So confinement reinforcement, three questions we had: diameter, spacing, and obviously arrangement also matters, but along with arrangement, sorry, yeah. So diameter, extent, and spacing. And obviously when all this diameter basically depends on the link arrangement that you are providing. Okay, so this is not a question, but to solve your question, to solve your one one of the questions. This is very important consideration. This is very important consideration. So I hope it is clear to all of you, right? Confinement, reinforcement in columns. Okay. So this is it for today's lesson. If you have any doubt regarding this, you can always write me in the chat so that I can clear your doubt as well as possible. So yes, I hope you are enjoying the course, and obviously anytime you can ask your doubts. I will try to, and I always try to solve the doubts as early as I can. And please do give me your feedbacks also regarding the course curriculum and regarding the lectures also. If you have any suggestion to improvement, it is always welcome. Please do let me know. I will try to impose your suggestions in my lectures. Thank you and see you in the next lecture.